Okay, chapter 13 is on exponents and scientific notation, and 13.1 is just exponents, and we've got a couple of things to talk about. If we just put a number out here, even if it's a fraction like 1/2, fraction, this whole number here is the base. And if we have an exponent, we put that as a little number up here. It's called the exponent. And a power is what all of this is. This whole thing is a power. Okay, so a lot of times we say to the second power, to the fifth power, but the 5 is the exponent. It's to the fifth power, but the 5 is the exponent. What we're looking at here when we have 1/2 to the fifth power, it's really it's how many times does this power, this whole thing is the power, how many times is 1/2 multiplied by itself? So 1/2 times 1/2 times 1/2 times 1/2, one more, times 1/2. If I get rid of this just for a second, 1/2 times 1/2 is 5 times. So 1/2 times itself 5 times would equal 1. 2 times 2 is 4, times 2 is 8, 16, 32. 32nd. Okay, so that's how that's going to work. We're just gonna use it like that. It's a fact. Now, one thing to look at. Let me see if I can go ahead and grab this again. If we do something like 3 1/3 to this. Let's make it look a little nicer. Let's do that 1/2 again. 1/2 to the second power. Notice how I have a parenthesis here. If I don't really have the parenthesis, then it might be that the second power just applies to the 1. When I apply the parenthesis, it's like saying 1 to the second over 2 to the second. 1 to the second power is just 1, and 2 to the second power is 4. So it's that 1/2 times 1/2. It's all 2 times. We get 1/4. If we don't have this exponent, it doesn't work as well. So that's one of the things we definitely have to make sure we look at from time to time, because that parenthesis makes a big difference about what we get. For instance, if we have -7, this is another example, times -7 times -7. And you can do it just like this, or you can put that little multiplication dot in there. There's 3 -7s, so this would be -7 to the third power. But that's very different than if I say -7 to the third power. These are not the same. Without the parenthesis, this is like saying -7 times 7 times 7. So 7 to the third power is 7 times 7 times 7, which is, a pretty big number. We could go up real quick just to see what it is. 7 times 7 is 49, times 7 is going to be 343. So this one, because it's -7 times -7, which would be a positive 49, 343. I should write that down. Alright, so this is -343. -7 times -7 is a positive 49, times another -7 is a -343. If we write it this way, we still get -343. So you could say, what's the big deal? -7 to the third power is -7 times +7, which is a -49, times a +7, which is also going to be a -343. The real big difference is if this exponent is ever an even number. Say we did -7 to the second power versus -7 to the second power without the parenthesis. This one is equal to -7 times -7, which is a positive 49. -7 times -7 is positive 49. But here we still have -7 times 7, just like we did up here. And this is a -49. So we have a positive answer and a negative answer depending on whether we use this parenthesis or not. And the reason it's confusing is because it seems to not matter on odd exponents, but it definitely does on even. Because if you multiply two negatives together, you get a positive. If you multiply 4 negatives together, you get a positive. If you multiply 8 negatives together, you get a positive. But if you multiply 3, it's negative, or 5 or 7, it's negative. So odd numbers end up being negative on those exponents. What do we do with something like, this is pi times r, which could be radius, times r. Okay, so pi is used twice, so that's going to be the same thing as pi to the second power. Pi times pi squared. R is used 3 times, so that's going to be r to the third power. And you could just write that without even that dot in the middle. Pi squared r cubed, or pi to the second r to the third. Pretty cool. So yeah, that's kind of how that works. What happens when we have negative 2 to the fourth? We have to go ahead and write that out as negative 2 times negative 2 times negative 2 times negative 2. We just have to do it. We may not want to. Negative 2 times negative 2 is a positive 4. Positive 4 times a negative 2 ends up being a negative 8. And negative 8 times a negative 2 ends up being a positive 16. So we get a positive number out of that. Okay, hopefully that makes some sense to you. But if we do something else, negative 2 to the fourth, this is again the same example that we showed on the other page, but you're seeing it again because it looks like negative 2 times 2 times 2 times 2, because this negative sign ends up being applied after. Exponents are first. If you remember, your PEMDAS or your parentheses are first. Exponents beat everything. These exponents happen before this negative gets applied. So you got this is equal to negative 16, because 2 times 2 times 2 is 16 with the negative outside. Alright, pretty cool. Trying to make this one a short one. Using order of operations. Okay, so this is cool, of course. You got 3 plus 2 times 3 to the fourth. Remember that you always have to evaluate the power before multiplications. So you're not going to do 2 times 3 and get 6 and take 6 to the fourth power. You're actually going to do the 3 to the fourth power first. So if I come down here and rewrite it, I'm going to rewrite it. 3 to the fourth is 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so this becomes this, and we don't multiply the 2 until after we've gotten rid of the power. And we also don't do the addition until after we've done the multiplication. So 2 times 81 is 162. Okay, and then we do one final step to include that addition. So it's 3 plus 162 is 165. Okay? Very important. You're going to do the powers first. Then you're going to do multiplication and division. Oh, sorry, I got distracted because I started thinking about I don't use this one. P, powers, exponent, PEM, D, addition and subtraction. Okay, I get it now. Alright, so this is not powers, this is parentheses. We got to remember, powers could be P, but we're going to call this exponents just to make sure that we don't get confused. So like 2 to the second. Multiplication is like the times, division, add, and subtract. And everything is always left to right. So I know that you've learned that before. This is an important concept that's going to work into what you're doing. The second example is 3 to the third power minus 8 to the second power divided by 2. And I always like to work down. I'll just rewrite things. And 3 to the third power is 27. 8 to the second power is 16. Now I've left this minus sign alone because it's still separating this and this. But now I can work left to right. 27 take away 16. Oh, 8 to the second is not 16. Thank you for calling on me on the phone and letting me know that I'd made a silly mistake. Sometimes I do that. Uh-oh. Come on. I was going to erase this 16. I don't want that. I want that. that. Yeah. And then go back to that. Alright, so 64. There we go. 27 minus 64 minus 2. Oh, that's not even a minus sign. That's supposed to be a divided by. Okay, that helps. That changes it up. Should I go back and start over so you can see that from the beginning? 3 to the third power minus 8 to the second power divided by 2. I didn't write the problem down wrong. Okay, we come down. 3 to the third power is 27. 8 to the second power is 64. Notice I've just left that minus sign in between. And I'm going to just come over and write the divided by 2, because I can't divide it by 2 till after I've written it. I got to make sure I keep track of my steps. 27 I'm going to leave alone because this is a subtraction problem. But I am going to take my 64 divided by 2 and turn that into, what is that, 32? Alright, and then I'm going to look at 27 minus 32 and think that the difference between 27 and 32 is only 5, but since there's more negatives, it's going to be negative 5. And that's my final answer. Would have gotten it over here too, eventually. Okay, so, sorry for that. Maybe I should do you one small favor. I should do one more problem. This is one of your examples. 9 minus 2 to the fifth power times, using the dot, 0.5, which is like 1/2. Alright, so we're just going to come right down here. We're going to leave the 9 alone, and we're going to do 2 to the fifth power. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 8, 16, 32. So, 32 times 0.5, or 1/2. Do I know what half of 32 is? I can do that in my head. That's 16. Hopefully you could too. If you use this 0.5, you end up with a calculator. I don't want you to use a calculator if you can help it. I want you to change it and make it so that it's something you can do in your head. And the difference between 9 and 16 is 7, and that's more negative, so it's going to be negative 7. 7 plus 9 is 16. Works out. Alright. Great job. We're done. Get to work.